Hello. How are you guys? Awesome. It's really good to be here. A big thank you to the fine folks at FITC for inviting me to be here with you guys today, and for making me go first, which I dearly love going first, getting you guys all warmed up. And a big thank you to all of you here for showing up. And thank yourselves for coming here today. You know, like your yoga teacher says at the end of the class, thank yourselves for coming here today. You've done yourselves, you've done something good for yourselves. I'm excited. I think we're going to have some fun. So by way of brief introduction, my name's Mark. My education is in electrical engineering and philosophy. I've worked in consumer electronics, automotive design, among a lot of other things. And these days I work at a place called Smith. Smith is an e-commerce company. They do big commerce platforms, big back-end stuff. And at Smith, I'm part of something called Smith Labs, which is a new group, and we are nominally interested in all emerging technologies that will have potential applications in commerce. But we spend most of our time thinking about augmented reality and how things will be in the future. At least that's how I keep myself busy. So what's interesting about AR right now, what I really like about it is that it's still really, really early days. This stuff just barely works. Compared to what we can reasonably predict is going to be coming in a few years, which is cool. And we're lucky these days, those of us who are interested in media in general, as I am, because we've been able to observe the advent and the development of a whole bunch of new media, personal computers, the internet, mobile computing, and now augmented reality. The new media used to come along every few thousand years. You had the invention of writing, and that was great, and we rolled on that for a while, and then you had the printing press, and then they came along a little bit more frequently. In the 19th century, you got photography and radio and telegraph, and then the 20th century, things really took off, and it's been about every 10 years. For the last 40 years, since I was a little kid, a long time ago. Something new comes up, and it changes the way we do everything in amazing ways. So this is just fascinating to me. It's really exciting to be able to watch this stuff, because each one of these new media is like a natural experiment. It's like an astronomer observing, some spectacular supernova that changes their models of how stars work and stuff like that, and they're happening like boom, all the time. And when you can get out in front of something, like ahead of it, like AR, and you can have a really good time making predictions about how it's going to evolve and what its most important qualities and characteristics are going to be, beyond the hype, right? And so this is what I'm going to try and do with you guys here today. I want to share some ideas about what AR's final form is going to be, besides what we're getting right now. How we're going to use it, what it'll mean to us, how it's going to work, in fact. And I'll also share some technical ideas about how we can start to work with it using what we've got access to right now in a way that anticipates this and that prefigures what is coming. And what is coming beyond like wider view and brighter and smaller pixels and more of them. There's something else that's coming in the world of mixed reality, and something that I think is going to be absolutely central to what we do with this stuff and why it'll be important. And not many people are talking about it right now, which is kind of weird. Or, I'm completely wrong. But I'm pretty sure that what I'm about to tell you guys is what's going to make these things as important, as much of a must-have bit of tech as personal computers or smartphones. And it's the locative nature of the medium. It's its rootedness in a particular place or location that is going to be its defining feature. So the word locative, it's kind of the best word we have. It's kind of a weird word. It denotes a grammatical sense where a word is meant to indicate a place in, or a place at which, I put the beer in the fridge. The in the fridge part is the locative part. So it's the best word we've got right now, and I guess it'll have to do. So it is the connection with reality, which is still a little bit tenuous right now, which I think is where the magic is really going to happen. Talk about augmented reality has been all about the augmented part and a lot less about reality. And I think this is going to change. A new shared network of information is going to emerge, rooted fundamentally in location, in place, which is going to enable really transformative experiences and is straight up going to give us new superpowers. So the state of the art, most of us, giving you guys the benefit of the doubt, are pretty familiar with how most currently available AR systems work these days, but I want to quickly walk us through where we are right now, a little bit about how we got here, so we can make some better guesses about where all of this stuff is going to go. Two problems AR systems need to solve in order to do what they do, and the first is to figure out the position and pose of the camera. And the interesting thing is that this is actually information about the world relative to the camera. It's not about the camera, actually, if you think about it right. The second problem that they need to solve is to gather whatever information they can about the immediate environment. So you need to be aware of the world around you, at least in some way, to be able to add anything to it, right? Like this is all about registration. Being able to add content that lines up with what's already there and behaves in a way that lines up with and is consistent with reality. Those of you who have been working with AR for a few years will remember how we used to do this. We used to do this with fiducial markers. What the hell were these things for? It's a bit of a hack, actually, but it's what you had to do to make it work. It's much easier to detect a known image, something specific that you're looking for, and find it, and then calculate the relative position of the camera and its angle and stuff like that, based on the apparent size and shape of the image, how far away the camera is, the angle of view. These are old Vuforia markers from like the olden times of, I think, 2 or 3 years ago. It's amazing. And so mobile devices of a few years ago weren't all that powerful, not like they are now. And they weren't really able to do this without cheating a little bit like this. In fact, what the marker does is it gives you some information about the world. You know, in your application, you're expecting the marker to be on a table, on a horizontal surface, and the dragon is sitting up on it. All you know about the world is, you know, your alignment with the target and your assumptions about what the target is doing. It gives you an anchor point in space, and it's all you really know about the world. So recently, just a few months ago, we got ARKit from Apple, we got ARCore from Google, and really truly wonderful integration of these platforms with Unity, which is so amazing that it feels like cheating to an old guy like me who comes from a time when everything was hard. And we don't need the markers anymore. So the hardware's a lot better than it used to be, the cameras are better, the processors are faster, and critically the sensors are much better. And part of the secret of ARKit's awesomeness is how good the accelerometers and gyroscopes really are in the new iPhones. And also how well calibrated and characterized they are. Apple's able to do this because they do the hardware and the software. And we have better image processing algorithms. SLAM, simultaneous location and mapping, works really well on this stuff. And there are good methods like Kalman filters, which is an old thing from robotics, that we use to fuse information from the hardware sensors and from the visual motion tracking into a single sort of coherent and workably accurate picture of how the device is moving and what its pose is. So this is my kitchen counter with a nice cube on it, which is pretty fancy. And I turned all the debug stuff on so you can see the little yellow points that the system's using to track the movement of the camera. And you can see the outline of the horizontal surface of the counter that it has detected and said, right, this is what we're going to be working with. You can also see the cube is actually lit. It figured out where the light is coming from, and you can't see it, but off to the top left, there's a nice window in my kitchen. And it figured out the shadows, and it lit the cube. It just did this automatically. So this is really cool. This is a really good trick. And of course, we've got even fancier stuff with the latest head-mounted devices, like the HoloLens from Microsoft. We've got a bunch of those at the office, which I must say is quite an impressive bit of gear. They did a really good job on this thing. So what these things do is they also use visual SLAM. They've got cameras on them, they've got accelerometers and gyroscopes. But they have another trick, which is still kind of rare on mobile phones, and that is a proper depth camera. So in the case of the HoloLens, it's sort of like version 3 of the Kinect. It's smaller, it's lower power, it's suitable for a head-mounted device. And it lets you build a much more detailed and sophisticated model, although still kind of primitive in its way, of the geometry of the local space. And this enables experiences that fit even better with the space around you. It can see the walls and floors and ceiling, and it can even remember in sort of a limited way spaces that it has seen before. And then there's whatever these guys are going to come up with, these guys in Florida. This was just news from this week. The latest is that they're going to do a soft launch to a limited number of developers, Q2 2018. So that's like the next 6 months or so, maybe. I guess we'll see, finally, or maybe not. So I'm expecting some, actually one of the guys on my team at Smith interviewed with Magic Leap, flew down to Florida. He's been in the machine. He's seen the dragon sitting on the table. He's pretty cagey about it because they scared him really bad with the NDA. But he says it's reasonable to expect, in the most general terms, some improvements in visual aspects, depth of field, things like that. Overall, I think we can expect it to look pretty good if we ever get a look at it. But as far as the environment sensing abilities of this, as far as its ability to model the space around it, I don't expect anything revolutionary to be coming from these guys, at least not for 1.0 if it ever drops. So all of these platforms and anything that we're likely to see in the next couple of years, anything that we're looking forward to, they all have a very serious limitation. There's something that they can't do, or at least they can't do it at the level where it would become really useful. All they know about the world around them, all the information that they have about the geometry of nearby space is completely local and ad hoc. And there's nothing that can orient this local model of space with respect to the world, the rest of the world. You don't really know where in the world you are, or how you're oriented with respect to the world. I mean, like the real world, right? Or what in the world you're looking at. You don't know any of that stuff. And it's a really big weakness of these platforms, at least how they work these days, and it means that all of the things that we can build on them, the experiences that we can create with them, are totally local, single-person experiences. There's no good way right now to share an AR experience in real time, which is funny once you start thinking about it. So, yeah, and AR apps on all of the platforms now, the head-mounted devices or mobile or whatever, are almost all strictly single-player mode. So this weakness, this lack, I think will eventually go away. It's going to be resolved. And my thesis here today, my idea that got me excited enough to agree to come and talk to you guys today, it's that we're not ever really going to figure out what this stuff is really for until this problem is solved. Until we're able to know not just where some horizontal or vertical surface is around us, but exactly where we are in the world, exactly what is all around us. Only then, I think, will the next medium emerge. And only then are we actually really going to figure out what the killer apps for AR are going to be. So, this is not me. I found this on the internet. But it might as well be me, in 1982. AR is, right now, kind of like how personal computers were in the late 70s and the early 80s. Those of you who weren't there can just take my word for it. So when personal computers first appeared, there were things like, Commodore 64, the TRS-80 like this. I had one. I have one still. It's in my basement, but I'm afraid to plug it in. or the ZX81 or a bunch of other things like this. They were, hooked up to the shitty TV in the rec room in the basement. And they were marketed as being the future, but they really didn't do very much. You could play video games on them, still not as good as the games at the arcade, but they were okay. Some of us actually learned to program these devices in BASIC and later assembler, the geeks. And there might have been some people who actually used them to balance their checkbooks or friggin' store their recipes or whatever the commercials suggested you were supposed to do with these things. But probably not very many of them. And even the first Macintoshes and the first PCs with graphical interfaces, they were good for word processing and desktop publishing, not really very much else. So, you guys recognize this guy? It's Isaac Asimov, right? It's awesome. So, it wasn't until the 90s, when the internet became a thing for everyone, that we finally figured out what these machines were for. It was only once we connected these things together on a network that the real killer apps emerged. These things were for talking to each other and sharing stuff, There was email, the World Wide Web, e-commerce, social media, all of that stuff, all the things that, that we do with our machines today didn't happen. So AR right now is like computers were in the 80s. There's no sharing of experiences, everything's a single-player game. There's nothing like the web that connects these devices and enables us to share and to see the same stuff. Almost all the applications we've got so far, even the measuring tape, which is really cool, all of that stuff, they're really kind of like the word processor on the TRS-80. They're useful, but a quarter-inch discs and walk it over. There wasn't any cyberspace, right? Not really. It's a picture of cyberspace. This is what cyberspace looks like. Like this, usually blue. Sometimes it's green. I had a lot of fun looking for pictures of cyberspace on the internet. And it's funny because it's always drawn in a kind of geometric way, right? Like it's always like a 3D grid off into infinity, and it's all made of green electricity. Which is funny because what was special about cyberspace, the feature, the characteristic of it that enabled all of the really powerful applications of it was that it existed outside of space, outside and beyond the idea of physical dimension. It collapsed distance to where you could be anywhere in a few hundred milliseconds. The whole world shrank to a dimensionless point. And it was the medium that really, brought the global village into existence. And all of cyberspace's killer apps took full advantage of and leveraged this collapse or transcendence of physical space. The new AR medium that is just beginning to emerge, that we're just beginning to imagine now, and which doesn't have a cool name like cyberspace yet, right? But it will. We don't have names for these things yet, but we will, which is kind of it's cool to think about. You're thinking about a thing that doesn't have a name yet. Anyway, this new AR medium is going to be kind of like the web. It might actually run on the internet, like as a new application layer, except it'll be anchored in the real world. It will be indexed fundamentally by location. Its content will be bound necessarily to a real place in the real world. Kind of more like this, except more like the entire world mapped and indexed at millimeter scale, right? As the scaffolding on which we can hang all of this new content. The new medium is going to be all about adding to what's there already. So instead of collapsing space, it's going to inhabit it. Instead of it being an escape from reality, it's going to be an augmentation, a fulfillment of reality. Every street in every city, like the entire countryside, all the woods and forests, right? Every brick in every building in every town, the inside and outside of every building all over the world, millimeter scale. And of course, smart people at Google have already started working on a positioning service that uses visual data and very detailed maps for very accurate indoor positioning. GPS can get you close, within a handful of meters, but doesn't work all that well indoors. What will work, however, is a millimeter scale map of everything, everywhere. Finally accurate microlocation. There it goes. Yeah, this is already being done. There's already a rush by people in the autonomous vehicle business to gather all the data that they can about the world and to map it. Companies like Tesla are using their cars with all of their sensors to produce a map of all of the drivable roads in the world, down to millimeter scale, to enable autonomous driving. Every lamppost, every curb, every ripple in the road. And some thoughtful and interesting people are even arguing that, that these maps are going to be the most valuable asset that these companies produce. So like all of the rest of the technology that we usually think of as making up autonomous driving as being the value of these companies, the batteries, the sensors, the guidance algorithms, all of that will be commoditized at a furious rate, and the real value will be in the data about the world, the map of the world that enables all of this stuff. So the same kind of thing, a millimeter scale map of the whole world, is what's going to enable this new AR medium. By matching the local geometry that your super duper magic AR glasses of the future, these are just readers because I'm old, everything that it can sense about the world around itself, you'll be able to locate yourself with absolute precision in space anywhere in the world. We will have, in essence, a map of the world, the size of the world, at a scale of 1 mile to 1 mile, or 1 meter to 1 meter. And this is not a new idea. Of course, there really isn't anything new under the sun. This is a very short story by Jorge Luis Borges, who's a very smart writer from Buenos Aires, who wrote a lot of really smart and interesting short stories around the middle of the last century, some of which we're finally catching up with. And this goes like this. I'm going to read this because it's nice and short and it's funny. So in that empire, the art of cartography attained such perfection that the map of a single province occupied the entirety of a city, and the map of the empire, the entirety of a province. In time, those unconscionable maps no longer satisfied, and the cartographers' guilds struck a map of the empire whose size was that of the empire, and which coincided point for point with it. The following generations, who were not so fond of the study of cartography as their forebears had been, saw that this vast map was useless, and not without some pitilessness was it that they delivered it up to the inclemencies of sun and winters. In the deserts of the West, still today there are tattered ruins of that map, inhabited by animals and beggars. In all the land, there is no other relic of the disciplines of geography. What's interesting about this story is that we're actually building such a map at a scale of 1 meter to 1 meter, a world-size map of the world. And far from being the useless sort of logical reductio ad absurdum that Borges describes, it will be actually the thing that enables the next medium, the AR1, that we still don't have a name for. So I'm not exactly sure what will come of this new locative AR medium, except that, I'm pretty sure it will surprise us. But I am damn sure that whatever the killer apps end up being, they will leverage the new superpowers that this technology will give us, being able to layer information, content, art, commerce, love, politics, good things, bad things, layering all of this on top of the real world all around us. Location and reality are the kernel of what this is going to be able to do. And anything meaningful or valuable that we do with it must leverage this. In just the same way, I'm arguing, as cyberspace's killer apps leveraged the transcendence of physical space. Yeah? Makes sense. And there are some interesting things that are already happening that I'd like to share with you. Let me see if this can work. Okay, cool. So there isn't any sound, so don't worry that there's no sound. So there are some interesting experiments being done, sort of forays into the future of locative media. Some of the first experiments in shareable AR experiences, shared contexts. These are the folks at Escher Reality, and look what they're doing. Each of them has their AR mobile device, and they're playing a game, and they can see the same ball in physical space, rendered from a couple of different positions. So what they're building at Escher Reality is a cross-platform solution that promises to enable multi-user experiences like this, and what they call, sort of mysteriously, persistent content. Whoops. I'm trying to make that go again, but I don't know if it will. So, so this looks like it's getting close at what I'm talking about. They're still in beta, as far as I know, but things move pretty quick. So how the hell does that work? Anyone got an idea? Like somehow you've got to be able to share a coordinate system. So you need to be able to render things in space from more than one point of view, which means somewhere you need a common anchor point. And I'm not sure how these guys do it because they're super cagey about it. But you can imagine picking out a feature in local space. I think things like corners of rooms are really good candidates. It's really easy to detect these planes, and you could probably figure out where they all intersect. And that's as good an origin as anything, and everyone can see it. One way or another, you need a way of aligning the ad hoc world spaces of each viewing camera with each other in a common coordinate system. That's the trick. So if you wanted to try this at home, the way we're trying this at home, you can fall back on an old hack that we all used to use, and that is using a fiducial marker. So rather than trying to solve the possibly quite difficult problem of finding a salient feature in the real world that you can all agree on as a common point, you can give yourself a fiducial marker and find that. And so you can say, aha, okay, we know the origin is in the middle here, and everyone can reconcile and draw the flaming, bouncing balls in the right spots on everybody's screens. It might be an easier way to get this kind of thing working. I think. I haven't actually got it working myself. It's tricky. The old version of Vuforia that's really good at fiducial markers will not build in Unity with ARKit because it's broken for now. But we're actually working on using image recognition libraries from OpenCV, which also has excellent integration in Unity, to do the glyph recognition and calculation of position and pose and all of that stuff. Or you can wait another month or two for Vuforia 7 to drop, and they promise all of this stuff is going to be fixed. So anyone who's interested in trying this, come and find me later and I can give you some pointers. With the understanding, of course, I haven't actually got it working yet. Oh, it did play again. Oh, I don't know how any of this stuff works. Then there's this. This is a really charming kind of augmented reality global graffiti application. Anyone wants to get their phones out and install this right now, basically what it lets you do is draw on the world with your finger, like a brush, as it were, either by moving your phone through space or drawing on the thing, and then save your drawings in a place wherever it was you drew it. And then anyone using the app can see everything that everyone else has drawn. It kind of sort of works, but it's super interesting. It actually uses GPS and the compass to figure out your azimuth and your location. So where you draw something doesn't register with any great accuracy. You can sort of be in the neighborhood, but if you wanted to, draw a hat on my head, even if I was standing still, it might be a few meters this way or that way. But it does work. And it uses SLAM for the finer movements. So there's lots of potential for some very fine mischief. I've done a few scribbles around here this morning, so if you run WorldBrush, you should be able to see. I tried to, draw letters and stuff, but it just wasn't happening, and I ran out of time. So there's some crude scribbles here. There's some all over the place. All of the meeting rooms at my office in Ottawa are full of obscene scratchings I met a guy at the beginning I was talking to, and he said it turns the whole world into a bathroom wall, which I guess in a way it does. But this is the kind of thing, this is how it's going to be. Stuff anchored in the world, stuff that you can add, stuff that other people can share with you. This is kind of what I'm talking about. Anyway, pretty cool. A bit of a vision of the future. And it raises some interesting questions, like if you've got a batch of new apps that allow users to create hidden graffiti using augmented reality, well, who is legally allowed to tag a place? If you went out in front of the building and said, OCAD sucks, I guess it's probably free expression. Physical graffiti like this stuff, this is from here in Toronto, there's so much great graffiti in this town. It's illegal, right? Without the permission of a property owner, which makes it not cool anymore. But what about virtual graffiti? Like if it's not immediately viewable by the public, how big a crime is it? Or if it's just for a group of friends, or patrons, or a bunch of nerds like us, at an AR conference, is it an intrusion on someone's property? And public expression, if I want to go and deface Centre Block in Parliament with World Brush and say, Trudeau is bad, or something really sophisticated like that, at what point is it free, where do we cross the line? Like when a space becomes public is a matter of law right now, but they're only talking about physical space. We don't have any laws for mixed reality and all of that stuff. It's interesting. All this stuff is going to happen. One more idea I want to share with you. I haven't built this myself, the Death Star over New York, but here's the idea. If you want to be able to add stuff to the world, but all you've got for location is GPS and a compass, well, the sky is a pretty good canvas. Content that's far away doesn't need any great accuracy for registration. As long as you get it close, it's going to look pretty good. So you could put a Death Star over Lake Ontario or over the CN Tower or something like that. And here's my idea, which I haven't tried yet, but I think should be possible. With some image processing that wouldn't be all that hard, you should be able to detect what part of an image is the sky and what part of the image is the foreground. The sky is usually, a limited set of colors. It's usually brighter, at least during the daytime. It's up and not down, which is a good clue. And you should be able to figure out what's foreground and what's background. So you could put the Death Star in New York and have it be occluded by the buildings, the trees, the people, anything that's there that's not the sky. It should just work. I don't think I'm going to have time ever to try this, so I'm putting it out there for all of you to maybe try and experiment with. Another thing that would be possible with something like this would be if you're sitting in, what do they call the Sky Dome these days? I used to live in Toronto, but I don't anymore. It's the Rogers Centre. Imagine sitting in the Rogers Centre at a baseball game and it's between innings, and you kind of know where you are, you know where the field is, GPS. You could have wrestling monsters in the infield in between innings on your AR. Like right now, you could do this stuff. Or at a hockey game, in between periods, you could have, instead of the Tim Hortons tiny guys, playing on the ice, you could have monsters playing hockey, or you could have, whales breaching in there, anything like this. The stuff we've got today is good enough for doing things like that. If the content is at a distance, registration works okay. And in a stadium, you can be pretty sure there's nothing between you and the field. Stuff like this should be possible. It's about putting stuff in the world, which is where I really wanted to go, because I think that's where all the magic is going to be. So there are a few things like this that seem to be headed in this direction that I think everything is eventually going to go. And I think that focusing on applications that are tied as closely as possible to as much of the real world as possible is a really fruitful path for discovering things that AR can do that are really going to be valuable and meaningful. So thank you all for your kind attention here today. Whether you agree with all this or not, it is a little bit theoretical. I hope I've given you something to think about, and maybe even something to go home and try out for yourselves. I am utterly fascinated by this, and I am so excited to see what happens. So enjoy the rest of the day. Come to the party tonight. I'll be there, and we'll see you all later.